All right, Math 2. Here we go. We've got 7-9, angles of elevation and depression. This is a section about word problems with right triangles. So our question is, how are the angles of elevation and depression related to each other? Explain. All right, so let's say that we have two people, one of them standing on top of a building up here. Don't worry, he's got a cape on. So he's going to be fine. He's got a cape. So nothing scary is happening here. And we got a person on the bottom looking up at that person there. So this guy's looking down. This person's looking up. So they have different perspectives on what's going on here, right? So if I'm looking at it, ding, 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 ding. So they have different perspectives. This person is looking at an angle that's elevated, so they're looking upwards. So we're looking at it and going, okay, their angle that they're looking at is this angle right here, and that is what we call the angle of elevation. Because it's elevated, which means raised. Okay, so they're looking, and there's their angle of elevation. But the guy on top, he's not looking at an elevator. He's not looking up. He's looking down. So he's looking at a completely different angle. This is the one that kind of throws people off sometimes. What we're doing here is his perspective of what like flat is way up here. That's where flat is to him, right? So for him, flat is up here, right? So whereas this person down here, flat is down here on the ground, this person's perspective, since he's raised up above the other one, has different perspective, and that would be up here. Now what we have here is parallel lines. So he's up here. His perspective is this is what flat is to him, or what horizontal is to him. Whereas the guy on the ground, horizontal to him is down here. So the guy on top, he has an angle of depression because he's looking down. So depress means to push down. So right here, he's looking down, and that's the angle of depression. Now, if you look at it, these are alternate interior angles. The angle of depression and the angle of elevation, therefore, should be the exact same angle because they're alternate interior angles. Now, in all these problems, we're going to be making right triangles. And the two right triangles that we see here are the same right triangle. Because it's like we got a rectangle, and then this would be the diagonal of the rectangle, just cutting it in half. So the vertical over here is parallel to the vertical over here. So these problems might ask us, we've got this guy's angle of elevation. How tall is the building? Okay, so we might use the angle to find the height of the building. Or we might say, okay, this guy's looking down here. How far away is this guy from the base of the building? So we might be finding this section here. But we're going to assume that the building and most things in here are built correctly with 90-degree angles. So we'd have a 90-degree angle there, and remember that's a 90-degree angle over there. So when we do these problems, you're probably going to make a little drawing of what's going on here. All right, so let's look at our first actual problem. The sun forms a 32-degree angle of depression, angle going down, with the top of a tree. I need a picture of that. What's that going to look like? All right, so we got the sun over here. Hey, sun, more. All right, so there's my sun, and it looks like I got a tree. So tree. Let's put the tree right here. So there's my tree. It's going to be a happy tree. So there's branches. And okay, there's my tree. All right, so the sun and light moves in a direct line. So the sun is going to kind of make this angle of depression with the tree. I need the ground. All right, so here's the ground. All right, so that's what I got so far. The sun forms a 32-degree angle of depression. Now, is this the angle of depression? No. Remember, the angle of depression is found by looking at what's horizontal to the top of the tree. And so this part right here would be our angle of depression. So there's our 32-degree angle. Let's read on. If the tree's shadow is 62 feet. Now, where's the shadow? Because every year I get kids that tell me that the shadow's floating in the air. No, the shadow's on the ground. So here's the shadow of the tree. Hey, where's my shadow? So there's the shadow of the tree on the ground, and it says the shadow of the tree is 62 feet. So here's my shadow down here. This is 62 feet. All right, how tall is the tree? All right, so I'm going to assume that this tree goes up and down, as trees do. Vertically, I'm going to assume that this is my 90-degree angle. So I want to find out x. All right, well, we got a little bit of problem because we got this 32-degree angle over here, and x is on this other triangle over here. So what we can do is we can make another right triangle on this side, where this is 90 degrees over here. So if this section is 62 feet here, that means that this section up here is also 62 feet. And that means that if this is the height of the tree over here, this is also the height of the tree over here. So now that we've got our drawing, we can go ahead and set up our trig function. So I've got my angle of reference is 32. It looks like I've got the opposite, and it looks like I've got the adjacent. So which trig function uses opposite and adjacent? Tangent does. So I'm going to do the tangent of 32 degrees equals x over 62. Okay, so I want to get x by itself, so I'm going to multiply both sides by 62. And that will reduce right there. So I get x is equal to 62 tangent of 32 degrees. So we just pull out our calculators. 62 times tangent 32 comes out to 38.7. Let's just say it's 39 feet tall approximately. So we would say it is approximately 39 feet tall. And now we have the height of our tree. And a beautiful picture that you can put up on your wall. All right, example 2. Jasmine leans a 30-foot ladder against her house to hang Christmas lights. Oh, I think we need a picture. Okay, so let's draw her house. So here's Jasmine's house. All right, Jasmine, there's your house. There's the ground. All right, so we got our house. She's going to lean a 30-foot ladder. That's a big ladder. So there's the ladder. And this should have a roof. What's wrong? Okay, roof. She's hanging Christmas lights. Do I have red? I do have red. Okay. All right, so there she's hanging some Christmas lights up on her tree. Should really put them on the roof line because it looks better up there. See? Jasmine. That's beautiful. All right, so there we go. There's Jasmine. And she's working really hard. Don't fall. All right, so next part. Oh, it's a 30-foot ladder. So this ladder here, that's 30 feet. Beautiful. All right, the bottom of the ladder is 7 feet away from the house. Let's see, bottom of the ladder, 7 feet from the house. Okay, so this is 7 feet. All right, what is the angle of elevation of the ladder? Well, where's angle of elevation? That is looking up. So we're looking for this angle right here, theta. We're going to assume that the house is built correctly and has perpendicular walls. So there's my right triangle. 7 feet away over here. The ladder's 30 feet over here. Our angle of elevation would be this one. So we are going to write down the opposite adjacent hypotenuse. So this one would be adjacent. This is the opposite leg. This is the hypotenuse. So we need to use adjacent and hypotenuse. Which one is that? It's cosine. So we're going to use cosine of theta is equal to 7 over 30 because it's adjacent over hypotenuse. How do we find the angle measurement? Inverse cosine. So we do theta is equal to the inverse cosine of 7 over 30. And let's see what we get. Second cosine, there's inverse cosine, 7 divided by 30 equals, it's 76.5, let's call it 77 degrees. Yay, math! So, on these word problems, draw your pictures. Elevation is always looking up. Depression is always looking down. Do not use this angle. That is not the angle of depression. It's the one with the false horizon up here. The horizontal that is not actually the ground. Okay, that's it. Have fun drawing pictures. See you guys later. Math hard. Bye-bye.